Alright, we're going to discuss some special instructions that will help you throughout the project. Definitely will help you throughout the project. Some of them you won't have to use them, some of them you will. I will give you some hints on other videos. I just want you to understand certain other instructions that might help you with this project and other projects. So the first instruction that I want to show you. So we covered all these, right? We covered normally open, normally closed. We cover equal, not equal to. Basically, these are inequalities, right? So you put a number on one side or a register on one side and a number on the other side and check if they're not equal to, right? It's very different from this one, which is a not, but it's a bit at a bit level. This is a value, a number, a numeric value. Less than or equal to, greater than or equal to. We have not covered the delta. For now, we will not cover that right now. We will cover it later on. What we will cover today will be the leading edge one-shot contact and the trailing edge one-shot contact. Basically, when we call a one-shot, it means that it will only be true or false for one scan time. Actually, it will be true for just one scan time. All right. So let's start with this one. Trailing edge. So notice there's like a symbol there, right? There is a symbol there. So let's put a value here like x1 or x0. Let's call this C0. Okay. And let's go ahead and put this one to x1. And over here C1. So notice that there is like a little symbol here. I don't know if you guys remember about the graph that we made before. It's very similar to the timing graph, right? Where when it's on the bottom, when it's low, it means it's off. And when it goes high, it's on. So this contact is monitoring just a transition from off to on. And will turn on, it'll be true, meaning it will provide a continuity, or basically it will turn on whatever it's here if the logic, all the other logic here is true. It will turn it on for one scan time. So it will turn it on for milliseconds, right? So let's try this real quick. Let's accept the change. Let's open our Do More Simulator. I give us go online with this project. So I'm online with this project. Let's write to the PLC. So status are on. Let's put it here to run mode. So notice that our C1 is off, right? Okay. Now look, this one is monitoring from off to on. And it will turn on for one scan time. Look what's going to happen real quick. It might happen really, really fast. So from off to on. It turned on this for milliseconds. It was so fast you weren't even able to see it. To prove my point, I'm going to put here a set instruction. Instead of an output, a set instruction. We accept the changes. Right to the PLC. Now look what's going to happen. So it's off, and it's only going to monitor the transition from off to on. And this is going to stay on no matter what. Even if it turns off again, it's going to stay on until a reset resets it. If you want to learn more about the set and reset, there's a previous video that talks about the set and reset. Please watch that video before watching this video. You will not understand this. So it goes from off to on. You see it turned on and it stayed on. So this turns on for a millisecond range. Why would you want to use this? Well, if you want to monitor just to change from off to on, a particular program or a particular process requires that, this is what you want to monitor. The same thing for this one, right? So notice that this one, when I download it, on its first scan time, it monitored that it was off, so it's on. So it should be on. Now I'm on, so I'm on the high level of my graph. When I turn it off, it should monitor. It was so fast, it did not even see it. So let's put a set instruction there. Okay. Edit mode. Let's set the changes right to the PLC. Now look at this. Look how interesting. It is on. It is on. Now it's gonna monitor if it goes from on to off, it's gonna turn it on. It's gonna throw basically it's gonna throw a pulse of on off to this set. And this, if this becomes true at any point in time, it's gonna stay on all the time. So you see, this is no longer on, now it's on. So this one is backwards, right? So this one monitors from off to on. Okay, another important instruction I want to show you will be this one. So let's say you have an equal to, let's say V1 equal to 10. This could be when it reaches a certain step, right? So you reach when you're equal to step 3. Let's say you want to open a valve, right? Or yeah, you want to open a valve, or not open a valve. Let's say when you're equal to step 3, and your low level switch, and this is a particular example, turns on. Not this one. Not this one. This one. So notice this one has the same symbol as this one's, but I'm not giving an address. So this one converts your entire, everything that's left to your rung, it will convert it to a, if all this is true, changes from false to true at one point. When I say false to true, is ending all this together, changes from false to true, it will turn on. So let's look at it. For now, let's use a move instruction that we used before. Let's say we were at step 3 and you want to go to step 4. So I recommend that every time you want to move like a value like this, like on a step sequence, you probably want to use this type of structure. Basically, it's like your formula to do it, right? So you hit accept, you write to your PLC. Now let's see what happens. So X2 is not on, so that's true. Now there's a V value there, right? So let's open our data view. Let's go V1. I'm going to edit it. And we're going to put a 3. Notice that as soon as this becomes 3, the entire rung goes from false to true. And I'm going to write it. And it's going to put a 4. It's going to put a 4 to V1. Let's say you initially had step 2, right? Step 2, you're not equal to 3 yet, right? Your switch is on. Now, you want to go to step 4. Once you hit 4, you write this. Oh, not 4. You want to go to 3. Once it equals to 3, you write it in. Look what's going to happen. Bam, you move to step 4. So now I have something at step 4, like saying when V1, which is your step value, equals step 4, you want to open a valve, let's say Y0, until you want to open that valve until you reach your high level switch. Your high level switch might be X0 or something like that. Once you're here, notice that once you reach the high levels, so basically if you want, the high level switch is going to be closed, right? So you're filling up the tank, for example. I'm not saying this is a particular example, right? So you're filling up your tank always here. When the high level switch is made, it turns to 1. This contact's going to open. You're no longer going to start filling. So you're going to get stuck if you don't move to another step. So the best way to do it is like saying X0 V1 equals to step 4. Now this is where you're going to put one of these. Remember, this is like your structure. You want to always use this. So you went here. Now you're going to put a move instruction here. And you're going to go move to step 5, for example. So when this becomes true, goes from off to on, you're going to go to step 5. So you're going to set the edits right to the PLC. So you're in step 4, right? You're opening your valve. You have not reached your high level switch. So it's going to keep opening because you have not reached your high level switch. Once you reach your high level switch, which is X0, look what's going to happen with V1, which carries your step. Bam, you move to step 5. Now in step 5, the same thing. You want to do something else. You want to drain the tank. So you put your logic here. Once you finish, then you want to put something that moves to the next step. And then you can move back to the first step where you started at. All right. I hope this video helps you a little bit to carry out your program. Let me know if there's anything you want answers to. You can write me up an email. Please do ask questions. See you next time.